Alright, how's everybody doing out there today in Math Magic Land? This is Miss Muscarella coming at you, and we are going to take a look at solving logarithmic equations, but this time we're going to take a look at another type, type 2, here where we are using log properties first. But first, let's take a look at the graph of log of x. Just to review a couple of things. Thing number one that I really want to talk about before we get going in this lesson is the domain of this function. I don't really care about the range because I'm going to talk about the domain. Now notice the domain. We've got this line over here where it just kind of takes a look like, nothing's going to cross the y-axis, which means for us, all of our x's have got to be greater than 0. So the domain of the log function is x is greater than 0. Of course, if you write this using interval notation, then it would be from 0 to infinity. So anytime that we have this function, we're going to have to pay attention to the domain, especially when we are solving equations that are logarithmic in nature. So let's continue on. Now we've already done 4 other examples in a previous video, but this is a second type, so we're going to kind of go along with the same idea here. Now check this out. A couple things. Log base 4, and log base 4. All of these have the same base. So we're going to use some log properties here for this example, and we're going to take these first two right here. Now remember, if you have subtracting, that means we're going to take log base 4 and we're going to rewrite this as x squared plus 5, all that over 7. And that's going to be equal to log base 4 of 2. Now from there, since both of our log base 4s are on each side, what we're going to do next is simply get rid of those, and we're going to take the x squared plus 5 over 7 and set that equal to 2. From here, this becomes simple arithmetic, algebra. You're going to multiply both sides by 7, which means you're going to get x squared plus 5 equals 14. Now there are 2 ways you could do this problem from here. It's going to depend on what you see first. So I'm going to do it one way like this. X squared equals, if you subtract that, you will get 9. Now don't forget, because this is where most people mess this up, do plus or minus the square root of 9, which we all know that to be plus or minus 3. So we get 2 possible answers there. Now you could have, perhaps, instead of doing it like that, you could have said x squared equals 9, and you could have subtracted that over to get x squared minus 9 equals 0 and solved it using factoring. So that would give you x plus 3 times x minus 3, that quantity set equal to 0. And then of course, each one of these x plus 3, you would set that equal to 0. So you're going to get x equals negative 3 for that term. And then x minus 3 equaling 0, you would get x equals positive 3. So either way, you would get the same answer. So we've gotten 2 values here for our x. Now the only thing we've got to do next is check it. So when you go to do the check, we're going to take a look at, so I'm going to write this kind of over here, even though I should do it underneath. But when you go to check it, I'm looking at the original equation, and anywhere there's an x, I'm going to substitute in a 3. So in this spot right here, that's the only term that has an x. So what I'm going to do is just plug in a negative 3 or positive 3, because I want this whole piece to be positive. Now, whether I square positive 3 or negative 3, this value of log base 4, of that blob, that's always going to be positive right there. Okay, and that's what I want, because remember that when you have log base 4 of whatever, that blob has got to be positive. So whether I put in positive 3 or I put in negative 3, I'm still going to get something that is going to be positive. So putting in plus or minus 3, I'm going to have, when I square that, I'll have 9 plus 5, which of course is 14. Log base 4 of 14, which is positive, which is what I need to do, is have something positive. So my answers are plus or minus 3 for the value of x. Onward. One more example. Now this particular example, I've got log base 4 again, and that we're using. Now, this one's going to use a really special property, and I want you to take a look over here at this piece. Log base 4 of 4. If the base is the same thing here, log base 4 of 4, that is really the same thing as just the number 1. A really good Beatles album, 1. For those of you who haven't checked it out, you probably should. It's a classic. The Beatles are awesome. So we're going to use those same properties again, log base 4 of x minus log base 4 of x plus 1, and we're going to set that up so that we have this fraction, log base 4 of x over x plus 1. We're going to set that equal to 1. Now from here, you could say, okay, 4 to the first power. 4 to the first power is going to be equal to the other piece, x over x plus 1. Now, 4 to the first power, of course, is 4, so I'm just going to go ahead and erase the little exponent there, because we know that 4 to the first power is 4. Now, to solve this, we're simply going to cross multiply, and 4 is the same thing as like 4 over 1. So when we cross multiply, we'll have 4 times the quantity x plus 1 is equal to 1 times x, which is just x. Distributing, now some people could probably do this at this level in your head, so you might even skip that last step we wrote and just go right to 4x plus 4 equals x. And then of course when you solve for this, 4 equals negative 3x, you'll get negative 4 over 3 for the value of x. Now, if I were to put that in anywhere, so I'm going to go ahead and do my check here. And I'm just going to do log base 4 of negative 4/3. What? Wait, this piece can't be negative. It's got to be positive. It's got to be greater than 0. So even though I got a value for x, it's not going to work. Can't do it. It's what we call an extraneous solution. We get an answer, but psych, it does not work. So you always want to make sure to check that. But let's not only take a look at it algebraically, let's take a look at it graphically. So here's our two pieces right here. On the bottom function right here is going to be the left-hand side, and then the top function, log base 4 of 4, of course, that's just like the line y equals 1. So you can tell these two functions never going to crisscross. Not going to happen. Thanks for playing. So whether we do it algebraically, we can also verify this graphically. Alright, boys and girls, thanks for checking out this video. And by now, you better be able to rock out solving log equations. All right, I'll catch up with you later. You guys have a great day. Peace out, Cub Scout.